serverless computing reduces the cost of using the cloud. Serverless also makes it easy to scale applications. The downside is that building serverless apps requires some mindset shift. Serverless functions are deployed to transient units of computation that are spun up on demand. This is in contrast to the typical model of application delivery, the deployment of an application to a server or a container that stays running until you shut it down. Robin Weston develops large projects with AWS Lambda, and he joined me for a discussion of how to build applications for serverless environments and how to do continuous delivery with serverless functions. One big appeal for continuous delivery fans is that serverless deployments are often smaller. The user is deploying something as small as a function. This was a fascinating episode for me. It was yet another introduction to why serverless is interesting, perhaps platform shifting level technology, and I think it'll be interesting to you too. In the information age, data is the new oil. Businesses need data, and there's no better data than real-time data, which is why Amazon Web Services built Amazon Kinesis, a powerful new way to collect, process, and analyze streaming data so that you can get timely insights and react quickly to new information. Here's the thing. Websites, mobile apps, IoT sensors, and the like can generate a colossal amount of streaming data, sometimes terabytes an hour. That, if processed in real time, can help you learn about what your customers, applications, and products are doing right now and respond right away. Amazon Kinesis from AWS lets you do that easily and at a low cost. With just a few clicks, you can start sending data from hundreds of thousands of data sources simultaneously. Loading in real time, it lets you process and analyze the data and take actions promptly. All you need to know is SQL. Kinesis also gives you the ability to build your own custom applications using popular stream processing frameworks of your choice. And with Kinesis, you only pay for the resources that you use. There are no minimums, no upfront commitments. To learn more about Kinesis, just go to kinesis.aws. That's kinesis.aws. And let's get streaming. Robin Weston is a lead consultant at ThoughtWorks. Robin, welcome to Software Engineering Daily.
It's great to be here.
So today we're talking about serverless and continuous delivery and the overlap between those two topics. And we've done a bunch of shows about serverless, but since it's a fairly new topic, I still feel like we should define it. So how do you define that term, serverless?
Straight away, we're into, land of strange definitions. I always start off, I've done a few talks on this. You call it out straight away that unfortunately it's a terrible name and has been seized upon by marketing folks. And so we can't get it back. Although I thought that was the case. But recently, I don't know if you've seen this, and particularly pertinent to you, is people are trying to rebrand it as Jeff. I don't know if you've seen that at all.
What? No,
yeah. No,
I haven't seen that.
No word of. So recently there was a Jeff conf. So basically they said, serverless is a terrible name. It adds more confusion. Let's call it something which has no opinions whatsoever. And what they chose was Jeff. So you can look it up. There was a Jeff conf recently, which was a conference about serverless architectures and functions as a service, but under the name of Jeff, because that took away any of the discussions around whether servers involved or whether they're not. So put to one side, so there's a kind of a fight back going against it. But
well, I certainly don't mind my name being associated with cutting edge technology, but the lack of opinion, I don't know, I don't consider myself totally objective, so
I don't know, maybe you need to get your image rights people on the case anyway, or your naming
Clearly.
rights. But so it's come to mean two things. The first of which is kind of the serverless architectures as a whole, which is not just functions as a service, but taking advantage of hosted solutions, for example, authentication like Auth0, or hosted databases. AWS provides a whole bunch and things like that. And there's there's more and more. I mean, the last show of yours I listened to was on Kafka running in the cloud. That you could use that as part of a service. To you as a consumer, it is serverless. You don't care what service it's running on. But it's also come to be known as the functions as a service. Part of it has also been known as serverless, which is a lot of the confusion. And that typically is what people are actually referring to. I think mainly just because it's newer and changes the way we think about technical architecture and the way we're building systems. So yeah, a few. And also, helpfully, there's this growing ecosystem of open source tooling around functions as a service, which is fantastic and a sign of a healthy ecosystem. But the most popular of those is also named serverless. So you have yet another definition. So mainly people are talking about functions as a service, but you always have to clarify which is adds to the confusion.
So there's two categories we're talking about when we're talking about serverless. Mm-hmm. One of them is platform as a service, which is something like the hosted Kafka product that you're talking about, where the idea is you don't have to manage or address any servers. You are managing or you're just addressing endpoints that are fulfilling the purposes of what something you had sitting on a server in the past might have accomplished. And then the other thing is functions as a service, which are basically you have kind of the same level of you have the same level of management in terms of the amount of code that you're writing, but you're getting scalability and you might be getting a lower cost than you would have if you were spinning up actual servers. And so we'll get into both of these topics, but I think it's worth going a little bit deeper because with the platform as a service stuff, you might be paying more. So if you were to host your own Kafka, for example, on your own EC2 instances, maybe you can control the costs a little bit better. But if you're using a provider, the provider is going to charge you a little bit more because you're paying for the management. However, with functions as a service, you're actually going to end up paying less. So I think that can be kind of confusing because when we're talking about serverless, it's not like you're going to be directly saving money because you're on serverless or losing money because you're on serverless. So delve into that a little bit more, like the cost-benefit analysis financially and computationally.
Yeah, no, that makes sense. I mean, I think actually with your first example where you said, well, you'd actually end up paying less if your example was Kafka, right? If you were hosting your own. I don't think there you're comparing apples with apples because sure, if you're adding up the AWS costs, right, then yes, it probably will be cheaper. But are you factoring in all your employees' time to keep that thing up and running and the maintenance cost of all the code you've written around the edges? And, I've not done it, but running a production Kafka cluster is no mean feat and requires a lot of skilled people putting a lot of effort in. And that is not cheap. We know that often in software companies, your biggest outlay is going to be the talent that you have within your organization. Mm-hmm. And so you've really got to factor that because that's what you're also paying if you're going with the Confluent hosted one. That's essentially you're also paying for the expertise of the Confluent folks at their end, providing you with a lovely scalable thing that just does what you need it to do. So those sums aren't often done. Totally comes, it's not just the people's time keeping the systems up and running, but also any code that they are writing to, build pipelines, keep things up and running, do disaster recovery, all that. You have to pay to maintain that code. There's a cost of that as well. And so you're kind of offloading all of that as well. So if you actually it's sometimes hard to do that maths, but if you do, I think you'll often find that you'll be actually far better off going with the platform as a service offering. So I just wanted to call that out. But yes, with the functions as a service, you can typically end up with that being cheaper, even if you're doing just the blind comparison of running the same code on your own instances versus splitting it up into functions as a service. Just because you're only paying for runtime, basically, think how much, actually, if you look at the utilization of the code that you're deploying, how much of the time is of that server sitting there are you actually actually paying for it, because you're going to get charged based on the lifetime of that server, regardless of its CPU level. But you don't want to run it at max, because that's dangerous and you're going to suffer performance issues. So yes, in that one, you kind of will often find you have quite big benefits out of the box, regardless of who's keeping it up and so on, just on pure code execution and so on.
In this article that you wrote about serverless continuous delivery, you gave the example of Splunk as a serverless product. And I think of Splunk as a perfect example of build versus buy in the serverless world. You could easily build, well, I don't want to say easily, but you could build your own server full logging solution, or you could buy a serverless logging solution where you're essentially paying a service provider to do all your logging and log management. So in this world where people can basically find a service to solve most of their problems, a lot of the people I talk to, they just say, okay, you should just buy everything, because if you're building a SaaS product, which most of the people that I talk to at least are building, some kind of software as a service thing, your margins are so high that you just need to focus on building your product and delivering that product to your customers and making more sales. How do you judge build versus buy today? What are the decisions where you would actually need to build something?
This is a great question. I mean, in my kind of day job working for ThoughtWorks, this is the question that comes up again and again and again. And the party line is it crucial? Is it your key differentiator to your business? Is it what gives you your edge over your competitors? Is it your secret sauce? And if it is, for sure, you want to build that yourself. And if not, buy it. But often we have to kind of convince our clients that actually that thing you're currently outsourcing, you need to bring that in-house, because that is your key differentiator, and you're at risk of, you might have hitched your cart to the wrong horse. And if that provider you're paying for that service, which is key to your business, they decide to go off in a separate direction, or I don't know, go out of business or something like that, that's your whole business model broken. So if it's key to you, then bring that in-house. You'd think that most of the time you'll be persuading people the other way, but actually often people try and outsource too much. It's a very interesting line. And I guess the decisions you're making on that will differ depending on where your company is at in their stage of growth, because early on you don't know what stuff is going to change a lot and which things you're going to need to customize, because you don't know how your product's going to fit into the market. And so over time it may well change.
And if you heard that Kafka episode, the managed Kafka episode, one of the things I asked Neha about in that episode was how she looks at the other competing cloud pub sub products like Amazon's Kinesis or Google Cloud Pub Sub. And this seems to be an interesting development in software as well, where you're not only making a build versus buy decision, even once you decide you're going to buy, you've got a cornucopia of options to choose from. And the integrations between these options are getting better. I mean, probably today, if you're entirely on AWS, maybe it's easier to have your Kinesis be your pub sub thing, but maybe not. And maybe not tomorrow. Maybe tomorrow it's just as easy to integrate Google's pub sub solution with that, or Confluence for that matter. So have you started to develop a framework or a way for assessing these different SaaS products, or are you mostly just kind of like going with what you hear is the best solution? I mean, how do you shop around?
There is. I don't think there's an answer I'm going to give, which is going to be the silver bullet. I'm a consultant, so I have to say it totally depends. But there are various factors that come into play. You're totally right about how likely is that those requirements going to change, and if so, going with something that be where the connection is maybe open source, or you can swap things out, or actually building that layer in yourself to give yourself that flexibility is worth doing. You've also got to bear in mind the skills of your people. There's no point, even if something is the best solution technically, but you have zero capability for your employees within your business, then that might not actually be the best pick. Or you decide, well, this is the best solution, we're going to have to get some training in. In terms of answering this in a more kind of holistic way, I don't claim to be a great knowledge on this, but the concept of evolutionary architecture, I can't remember if it's been spoken about on your show before, but it's something.
We did a show about that.
Probably with Neil Ford
That's right.
That I'm really excited about that, and I'm not saying this just to push ThoughtWorks. That is a lovely way of having, instead of it just being based on what's cool at the minute, or highest paid person's opinion or best technical person's opinion, actually having from the start what qualities do we need from our system, and having a kind of fitness function that you can continually use to evaluate your architecture and the qualities in it and what you actually care about. You can then apply that to your choices and then say, well, does it satisfy the qualities that we're after? Solution A, solution B, solution C, and you need to spike them out, but you have ahead of time a kind of unopinionated way of validating that your architectural decisions are moving in the right direction, your system's evolving in the way you want it to, and that way you have something to actually, a framework in place to try out different products, be they software as a service or whatever it is. And I really like that because it takes away a lot of the emotion out of it, because you will always have people that will be pushing for certain things because they want to play with them, and I'm no different. I suffer from that fault as much as lots of people in technology. So I'm keen to find out more about that when the book comes out, because I think that will really help guide these decisions.
The process of troubleshooting bugs can be tedious and inefficient for developers, especially as they push more and more code to production. The unlucky developer assigned to bug duty may get bombarded with error alerts and spend hours figuring out which errors to address first. They might have to deal with logs to piece together what happened, or even spend time reaching out to other engineers on their team for help. Bugsnag improves the task of troubleshooting errors by making it more enjoyable and less time-consuming. For example, when an error occurs, your team can get notified via Slack, see the diagnostic information on the error, and identify the developer who committed the code. Bugsnag's integration with Jira and other collaboration tools makes it easy to assign and track bugs as they are fixed. We have a special offer for Software Engineering Daily listeners. Try all features free for 60 days at bugsnag.com/sedaily. Development teams can now iterate faster and improve software quality. To get started, go to www.bugsnag.com/sedaily. Get up and running in 3 minutes. Airbnb, Lyft, and Shopify all use Bugsnag to monitor application errors. Try all features free for 60 days at bugsnag.com/sedaily. Thank you, Bugsnag, for being a sponsor of Software Engineering Daily. It's much appreciated. Definitely. And speaking of things that are worth playing with, we can get into our functions as a service conversation now. I did want to spend a little bit of time on the discussion of SaaS serverless products like Splunk or Kinesis or Confluence, Kafka product, just because, like you said, you're a consultant and you spend a lot of time thinking about the cost structures of these products. And I mean, they're so interesting to me just because, I mean, I'm fairly new to software development compared to a lot of the people that I talk to, where I've only been in it for like 6 or 7 years. But even in that short frame of time, I've seen this dramatic shift from, okay, it's really hard to build something and you have to write everything yourself or pull it down from an open source repository, to a place where you can just buy stuff off the shelf and it's really easy to work with. And so I always like to ask people about these services just because it's so fascinating. But functions as a service. So Functions as a service, they are independent functions that we write to execute on servers somewhere that we're not addressing explicitly. So we write a function and we deploy it to Amazon or to Microsoft or to Google or whoever is our function as a service provider, and it executes on some opaque piece of infrastructure somewhere. Probably it gets spun up on a container, and that container may be on some shaky infrastructure, but we have certain guarantees about how that function is going to execute. Why do functions as a service exist? Let's just assume there are some people out there who they're still new to this topic, or they have not heard about it at all. So explain why functions as a service exist. Why does this thing even exist? Why is it offered?
That's a very good question. I think the first answer, it just gets you value quicker than previous methods, basically. The steps required for you to get code that actually has business value, so not boilerplate code, actually deployed somewhere, and I think you used the word addressable, which is quite nice, actually able to be run in a production-like environment, that time is reduced based on the way we previously used to write software. So that's a massive win. We're constantly trying to get our lead times down in feature delivery and flow of work through our systems, and this helps with that. Then you add in the cost factor, which we touched on earlier, and again, that can be, compared to depending on what your system is, you could be looking at orders of magnitude cheaper cost for systems which have the same behavior, and at scale that makes a big difference. And it works both ways, and it just allows you can use the functions as a service for your startup, which has minimal traffic, and you'll just pay for that, and if it ramps up, it will run as many functions as needs to, and you will only pay for them, but your ability to scale from the get-go is much more increased than it would be with a more traditional approach. I mean, how many tales do we hear of, Twitter being the obvious one, but companies that were suddenly so popular and just couldn't scale as quickly as they needed to. This just puts you in a much better position to deal with that scalability problem, which is a nice problem to have, but at the same time not paying huge amounts up front in preparation for traffic that might never come. Mm-hmm. So,
and one way I think about this, because I think some people who are listening, they might have a hard time understanding, okay, so it improves your ability to scale, to have your stuff in functions as a service, but it also costs less. And that might be confusing to some people because it seems like if it improves your ability to scale, how is it that this thing also costs less? And I think that the answer to that is that what functions as a service do is it creates more liquidity on both sides of the server market. Because basically, as a developer, if you're instead of presenting your entire application as a big chunk of code to run on a server or a set of servers somewhere that's hard for that provider to manage, you're presenting it as these broken up small blobs of code so that the provider can more easily distribute your little blobs of code across their servers so basically it's just this increase in liquidity because instead of having to deploy this entire monolith to one place, they're breaking it up into these smaller things, and then it just reduces the costs everywhere. Of course, in order to do that, the developer needs to break down their application into something that is consumable by serverless. So can you describe that process of we've done so many shows about re-architecting a monolith into microservices. Is this the same conversation? Are we just breaking our monolith up into microservices, and then our microservices can magically deploy to functions as a service, or is there something else we need to do in that re-architecture?
I think it is basically the same conversation. I mean, you're implying that we are breaking up existing applications, which, as opposed to building new ones, but yes, you're right. I think exactly the same rules that apply for breaking up an application, a monolith, as one would do with microservices, apply here. The same concepts of breaking it up by, applying good domain-driven design principles and bounded context and things like that. Those principles still apply. You could still make a right mess of splitting up a monolith into functions as a service, for sure. But I think you're into your actually looking at what your domain is and how you split that up. I think these patterns are evolving because previously with microservices, you would break it up as far as services, but obviously with functions as a service, you're going even smaller, more granular units than that. So we could get on to what we term microservices and the relationship between functions as services and microservices, how they fit together. And I have some kind of opinions on that. But yes, I think the general rules apply exactly the same. You look at you should base it, apply Conway's law, base it around your teams, have teams own a domain, that kind of thing.
Yeah, I would love to get into a discussion of how these things are actually used, because they cropped up in the last 18 to 24 months, I think, is when people started talking about functions as a service, maybe a little bit longer. What have we learned about using these things in projects and in production?
I can only speak from my own experience, so I'm sure other things are going on across the industry. I think initially a lot of the value people are finding in them is not diving in and rewriting like their core APIs or their core logic, which is the safe thing to do. They're using them to pick off things around the edges of their system, those triggered jobs, those cron jobs that always need to run that are just moving data from A to B, or background tasks, things like that, and getting used to it. So it's not kind of your core domain logic, and people are using these to get a sense of how functions as a service behave, how we can deploy them in a kind of non-mission critical manner. But as people are getting more comfortable with that, we're starting to focus more on the guts of our system where the really big wins can be made, but there is more risk there. What I have found has worked is still thinking in terms of microservices, in terms of the domain, and how you split it up around focusing around teams, and actually just having the functions as a service almost as an implementation detail within a microservice. Of course, this depends on what system you're working in, but what's worked for us is, even though in theory you could deploy every function independently, that would totally be possible. Swiftly, you're going to end up if you have a pipeline going from dev to production for every function, that is going to be swiftly very complicated to manage over time, and you're going to have to worry about all the things you have to worry about when you're worrying about microservices, dependencies between services, contracts, all that kind of thing. You've got that same problem, but you've probably just blown up the order of magnitude a lot more because you're deploying functions. So what I found easier is to treat a small group of functions as a kind of conceptual microservice, even though it isn't an application that you could lift and shift somewhere. Treat a group of functions, even if they don't communicate directly with each other, as a service, and they all go together and they all get deployed together. So even though you're not taking advantage of the super granular level, I think it's a slider, and there's a trade-off to be made between going with the individual functions and a larger group of them.
These serverless functions are triggered in response to events that happen. They are triggered in response to event sources. And as you mentioned, a lot of people are using these functions as a service to do these little side compute jobs where they just need to shift data from one place to another. Or maybe you could talk a little bit more about this. Explain this, give some more context, give an example of an event that we need some transient compute to respond to.
Yeah, cool. So a couple of classic examples. One I haven't used but is given a lot, and one that I have used. So the first is some kind of image manipulation. So maybe images get uploaded to your API website, whatever, but you need to create a thumbnail or pass it through a filter or something like that. So you would have your function subscribe let's talk AWS because it's probably simpler, but listening for images being dropped into an S3 bucket, your function would get called, the event data passed into your function would be, what bucket it was and what the name of the file is, and then you could go and do your transform in your Lambda and then write that new image back out to another bucket. And that function would only get run as and when images dropped in. So that's a classic example. One we've used it for is this is actually quite a nice example in that we had out of the box with Lambda, any, say in JavaScript, a console.log statement or the equivalent in whatever other language you're writing in Lambda, that log message will go into CloudWatch out the box, which is lovely, really nice feature. But after a while, you still have all these different log streams and you kind of want to aggregate them together. And log aggregation, we do it in our normal services a lot. So AWS provide you with a function definition they write for you that basically subscribes to CloudWatch, picks up any log messages that are coming in and grabs them and does a little bit of embellishment and then pops them into a Elasticsearch cluster where you've got Kibana on top and you can search through it and it's all aggregated. So you're using those, in that case, using your Lambda functions, just a little bit of glue between CloudWatch and Elasticsearch cluster where you can have better control over your aggregated set of logs. So they're two examples, kind of useful, kind of around the edges of your system, but still pretty critical to it.
And another use case that seems really practical, especially for really big companies with a lot of different data sources, is this issue where, and I did a whole show actually a different show with Neha about this event sourcing stuff. Basically, when you have, let's say you have some database that updates customer information, and then whenever that database gets updated, you also want a search index somewhere to be updated, because that's another database, but that needs to have a replication of the same data, but for a different purpose. You can use functions as a service to be the thing that updates the search index. So basically, you could use functions as a service to be the function that reconciles these different databases that you have. And this can be really important because at a large organization, you might have a ton of different databases and you need them to be subscribed to each other, and you need to have different updates occur.
Yeah, absolutely. I mean, it was always a strategy you could use if you had a big monolithic database and you were trying to, let's say, move to microservices or something like that. Migrating data is often the hardest part, and basically using database triggers, which are kind of considered a bit dirty nowadays, is a way of doing that, of having, taking data out as it flows in and moving it to another system, whether you're doing that just to move the data across, but also if you want to build a search index or something like that, and using functions as a service attached to a cloud-hosted database, say Dynamo, is essentially that. It's essentially database triggers for the modern cloud world, and you can achieve the same gains with it and beyond. It's just a bit nicer as well because just the whole way you write them and the whole way they're deployed is much nicer than database triggers. But yes, for sure, it's a good use case.
So the database triggers of the past that you mentioned were dirty. Was that something like where you would tail the database change log, which is like this lower level, or I guess it's what is it? There's some other log. Well, it's not called a change. It's basically a change log, but tailing a change log, I think that's dirtier because it's kind of this lower level thing that you're not actually supposed to be interfacing with as a developer. Whereas the systems like DynamoDB, that hosted database service on Amazon, that actually publishes a change log type of eventing system that is actually made for developers to interact with it. Am I phrasing that correctly?
Yeah. You're interacting with an API that's actually designed for your usage. I mean, I wasn't actually referring to the underlying log in a database. I was talking about, so in, let's say, SQL Server, you have triggers are a known thing, and you can, write a trigger which, gets run when updates come against a certain table. And it's a first-class citizen of the language, but they were became a bit dirty just because you're basically embedding your business logic deep within the database, and it was never that easy to how do you deploy updates to that. The logic would be hidden away, and it was very hard to reason about it, and so on. And there were performance concerns as well. But yes, nowadays database triggers, there'd have to be a very good reason why you would use them. But yeah, in this newer world, I don't think they have the same concerns for reasons that we've discussed.
We've motivated the use cases for functions as a service at this point. How do developers actually deploy these functions as a service?
Pretty easily is the answer. Out of the box, you can use the APIs provided to you by whatever cloud provider you go with. So typically that would involve either using the command line. They pretty much all have command line offerings, or calling the RESTful APIs yourself. And that's totally doable. More and more, we mentioned it earlier, there's kind of growing ecosystem of open source tooling around the edge of these providers is increasingly how people are using it, just because it provides some opinionated, typically they all provide some kind of opinionated command line tooling around how to deploy these functions. You're kind of entering into a deal where so let's use the serverless framework, as it's called. This is the other one of the other usages of the word, but they're basically saying, hey, if you put your function definitions in a folder structure like so, and you put some config and metadata in a folder like so, and then you run this command, I think it's just an npm tool, you run whatever the command is, serverless deploy, we will kind of spider through your directories, gather it all up, and basically deploy it for you as you've declared in your config files. And they'll do that work for you. So they'll be calling the APIs behind the scenes. And to get started, that's often quicker than having to kind of script it yourself.
Your enterprise wants to adopt containers, but you aren't sure how. CoreOS will help you along your journey to a containerized architecture. CoreOS are the container experts trusted by Salesforce, eBay, Ticketmaster, and other world-class organizations. Go to softwareengineeringdaily.com/CoreOS to find our top 5 episodes about containers and Kubernetes, as well as a white paper about migrating an enterprise to Kubernetes with CoreOS. They've hosted, attended, and spoken at many shows about containers and Kubernetes because those technologies are the future of the web. That's why CoreOS built Tectonic, an enterprise-ready Kubernetes platform. At softwareengineeringdaily.com/CoreOS, you can learn about how containers can make your organization run more efficiently. Thanks to CoreOS for being a sponsor of Software Engineering Daily. I want to get into a conversation of how continuous delivery works with functions as a service. You've said that continuous delivery is made easier when the deployable units are smaller, and it doesn't get much smaller than a function. Why is it that continuous delivery does become easier when you have smaller units of deployment?
Again, these answers you can basically apply. One of the main reasons why microservices exist. In the world of a monolith, you can only deploy the monolith, and you can therefore, your batch sizes are typically higher. Deployments typically take longer. You will have more changes baked into there. There's more things that could go wrong. It takes longer to recover it from failure. All of that, and so a lot of the reason that microservices came to exist, and that allowing a team to own their own path to production, own that whole flow, and therefore be able to deliver value through the system much quicker is the same reason that you get those benefits on functions as a service. It's just that functions as a service from the offset are forcing you to think small because you have to. That's the unit you have. And so it just puts you in that frame of thinking. So you're kind of coming at it from the other angle. Instead of thinking, well, how can we chunk up our system so it can be deployed? We can decouple our system and deploy things independently. You're coming out from the other end and say, well, how many of these functions do I need to put together to deliver some value? And can they just go up together? So the same arguments.
Mm-hmm. You also point out that because you can't test functions as a service locally, that can actually be an advantage to getting an effective continuous delivery pipeline. And to emphasize why you can't test them locally, it's because I don't have a data center sitting in my apartment that I can deploy them to on transient compute. And to realistically test a function as a service, you want to deploy it to an environment that resembles the function as a service environment, which only exists in the functions as a service environment. So explain why that's actually an advantage.
So I think it's worth clarifying the word can't in there is kind of in quote marks because so there's a couple of levels to this, I guess. So you're writing your functions as a service are just written in insert language of choice here, let's say JavaScript. You can absolutely totally test those functions, TDD them out, unit test them using your favorite JavaScript testing frameworks, Mocha, whatever. Not a problem with that. It's just code running code, not a problem. So for all your kind of that normal flow, you can totally test that locally. And it's really nice because you've got this consistent shape to your functions. They all have to, your interface is the same for each one. So your tests are naturally quite small and quite similar. And it really helps you test drive stuff out. So that kind of flow, fine. It's when you get into the kind of the higher level tests where you're wanting to, the simplest example is you've got your function, but you want to, it's triggered by an HTTP request. So that's probably one of the most common couplings between events and functions as a service. So you've got an endpoint that gets hit with some data, and that calls a function as a service to actually process that data. You can run that locally, but only through essentially someone has built a shim that mimics what that's set up for you locally. So the serverless framework does it for you. Other people have built other things that allow you to do that, but it's not true to how it would be running in the cloud. It's faked to some degree. So you can only rely on it as much as the quality of that shim is in place. So it will never be true. So you could just live with that, or you can just embrace the fact that, well, we can't really run this locally. So, and that's fine. Let's test it where it's going to be running, which is in the cloud. And normally, if you're building a more traditional application and you were saying, well, every time I want to run some kind of higher level functional test, I've got to deploy my system to the cloud, that's reasonably timely, and your feedback loop goes down because you have to deploy it and then run your tests. And then if they fail, you've got to fix it, deploy it, run your tests, blah, blah, blah. But because deploying functions as a service are typically much quicker because just the deployment size is smaller, there's just less going on, that feedback loop isn't too bad. And so what we found worked for us on previous projects is kind of just having each developer having their own little sandbox in the cloud that they can just run a script locally and it will deploy whatever they've got locally to their sandbox and run the functional test just in situ against the deployed system in the cloud. And locally, your tests don't care where it is. They're just hitting an endpoint with some, data and checking what comes out the other end. But what's lovely about that is you're testing it it's a much more production-like environment. And also you're exercising your deployment scripts continually because the developers are using them all the time. So you're going to be much more confident that they do what they should do. And when you're using them further on down your actual deployment pipeline. So yeah, I'm sure it's come up before in previous shows you've done about this kind of growth of testing in production being a thing, in that, you can run as many tests as you want in your pre-production environments, but things will always go wrong in production because it's the way the world works. It's the beautiful madness of,
or even just staging.
Sure, right? And so just embrace that and use it as a forcing function to get your good monitoring and operability in place, and think about synthetic transactions flowing through your system and things like that, which I know have come up in your previous shows before, and just kind of embrace it and let it naturally lead to those other practices instead of trying to cover all the bases on a local developer's machine.
So you mentioned some monitoring stuff. So how does logging and monitoring play into this conversation around functions as a service, continuous delivery? Because typically, I mean, a lot of deployments that I've seen, what they do is they deploy and they do like a canary deployment, and then the service serves 1% of the audience, and the 1% gives you some production data on how this thing is doing in production. But in order to accurately test that, you need to have good logging and monitoring around the deployable unit. And the typical logging and monitoring systems might write to the whatever the microservice is deployed to. If the microservice is deployed to a server, or I guess, well, it probably would be writing to some external service. So does logging and monitoring change in any meaningful way when we're deploying to functions as a service?
I mean, ultimately, what makes good logging and monitoring is good logging and monitoring. The rules don't change for functions as a service. You still want to know what your functions are doing. You want to know how they're performing. There's this kind of, just because it's a function as a service doesn't mean it's magically going to run fast and not consume any memory. Like, you can still commit horrific sins inside them, and I've seen it happen, and have performance issues because we're humans writing code. And so things will go wrong, but it helps you. What I found is it just gets you to a useful state quicker, in that, using Lambda as an example, and I think I mentioned it before, you just do a console.log line and bam, that log message is available in a persisted log store. Mm-hmm. Whereas I'm thinking of other systems I've worked on have had really good log aggregation systems, but they've been ones that the development team have had to kind of hand roll to some degree. Even if you're using, we touched on it earlier, even if you're using something like Splunk or Elk or anything like that, you've got to worry about log files, you've got to worry about moving those logs around, and maybe the clustering of the log system they're going to, and all that. That's not where you're making money. That's just a necessary implementation detail, I suppose. So it just gets you to that path quicker. And similar with monitoring, you get out the box with these functions as a service, typically some pretty useful monitoring out just from the get-go, things like latency and memory usage and failures and all that stuff. Pretty easy just to whack a few graphs up on a dashboard from the start with not that much effort. Whereas again, before, I've seen systems which had really good monitoring setups, and there's so many good tools out there, but still took a while to get that available, so all the services could easily just fire off some monitoring data and get it picked up, be it Graphite, or you've done shows on Prometheus and things like that. But there is effort there to integrate that in, and an ongoing cost and maintainability. And I'm not saying that the monitoring and logging you get out the box is perfect and you'll never need to change it. You probably will, and we found we needed to enhance it, but it gets you to something actionable and useful much quicker, and then you can move from there.
There are continuous delivery tools, like ThoughtWorks has GoCD, which, full disclosure, is a sponsor of this show, but there's plenty of other continuous delivery tools we could be talking about. Does FAS change the usage for these continuous delivery tools? Are we doing anything differently?
I don't think so. No, I think what makes a good CD tool is a good CD tool. I suspect, given time, I haven't looked recently, but some of these tools might start to provide out-the-box functionality around functions as a service, just in terms of maybe being able to, I don't know, deploy them or whatever. But there's this ecosystem around it anyway, so it's not hard to do that. You shouldn't be relying on your CD tool to do that. I think really you want to my approach is I just treat my CD tool as it's a fancy script executor, really, because you don't want to be doing too much programming in it at all. You want that all in your source controlled repository alongside the code that it's actually deploying. So no, I think good practices in continuous delivery and tooling just apply in general about having some representing your process as a pipeline, with quality gates and building your quality in is really important. And if your tool can help you do that, then that's great. I mean, again, I work for ThoughtWorks. I like Go just because its natural state is to visualize everything as a pipeline. But there are other tools you can use that. And on previous serverless systems I've worked on, we didn't use Go. We used something else, and it was fine. You just have good practices. You build your deployable artifacts once early on after they've gone through some testing, and you just promote those through the environments, reusing scripts to do the deployments and testing or whatever. That's all as it was. That's not really changed by functions as a service. You just changed the deployable artifact and the scripts that get it up to the cloud. But no, the tooling, I think, is much unchanged, really.
So if we zoomed out like 20 years and if we looked at how software delivery has changed over the last 20 years, it's been tremendous change. I mean, it's gone from deploying software to compact disks and, users buy new compact disks to where we are today with SaaS, and people can just deploy their software day to day and get it to users in the same instant with delivery. So how has the development and delivery process changed for you most recently? Because, I just know in my time in the industry, which, I've kind of been out of the industry for the last 2 years when I've just been reporting on podcasts. But even in my just 5 years when I was between school and starting this podcast, when I was actually in the industry, my workflow changed over that period of time based on the tooling that was available to me and the services that were available. So give me a picture for what's changing right now and what your workflow looks like, particularly when you're working with functions as a service. Just give me a picture for how software development and delivery works for you today.
Okay, that's a big question. I think in terms of the functions as a service stuff, so not everything I've worked on recently has involved those. So I'm just trying to separate in my mind those that I did. In terms of the workflow, I mean, the actual workflow was not that different to working on any system that's been well decomposed into small services owned by a given team. You had a repository or two that your team owned, and you would test drive out your code in there. You would write maybe a high level functional tests. You would think about what other testing needed to be done, and you would get it out as soon as possible into a production like environment and look at, and let your monitoring guide you. The sooner it's out there, the sooner you can get some feedback about how people use it, and the sooner you can get it in front of or consuming user traffic, I suppose, is the real thing. Whether it's actually live traffic that you're going to action, or whether it's just a side-by-side deployment that's just taking copies of production traffic just to see how it behaves, the better. But I think that's just much more achievable now, and the time you can take to get it out there is so much quicker and get that feedback. But I listen to a lot of your shows, and a lot of the people you speak to are from these, kind of companies at the bleeding edge, or it comes up a lot in discussions, your Amazons and your Google. But one of the things I guess I enjoy about being a consultant is I get to work with companies that, like, they're the people we hear about, but there's this kind of, I heard someone refer to it as this kind of like dark matter development, which is all the developers and all the work that goes on that isn't in the news and isn't blogged about, which probably makes up like 95% of the industry.
Oh yeah.
And I get plonked in the middle of that, and it's absolutely fascinating. And it is where, you just basically have to kind of adjust to where that company is in the industry. And it might be they are kind of 5 years, what was good 5 years ago is where they are now. And that's fine. And that's why you're there, and you have to kind of take them forward. So sometimes you get spoilt working on this functions as a service stuff, and often you have to take things right back to fundamentals. And as with everything, I know this isn't quite answering the question you asked, but often it's not about the technology. It's software is about the people that build it and the relationships between them, and that's often the hard stuff to address when you're trying to get software out the door quicker and with better quality. Often the technical bits that's not the hard stuff. It's having the conversations with all the parties involved, because there's often a lot of politics at play and things like that, and addressing it there. But I think it really helps that there are these companies leading the way, because it serves as a kind of shining light that this can be done. And also sometimes as a consultant, sometimes you have to rely on not scare tactics, but you can basically say, well, you could just choose to leave your current deployment process as it is, but ask yourself what happens if one of your competitors gets their act together and takes on this stuff and is suddenly releasing into production, getting features out an order of magnitude faster than you. Like, that is a massive business competitive advantage, and you use that as a lever to then do the technical work. But yeah, sorry, I digress. I'm just trying to. There's a much bigger world out there than we often think of, that are all various states of continuous delivery and deployment.
Absolutely, and I've tried to do some shows in those areas, kind of the more typical type of company. Like you said, it's 95% of probably software engineering is these companies that are not at the bleeding edge, and that stuff is equally interesting. It's not less interesting because it's not at the bleeding edge. In fact, some of the problems are more interesting because you have people management questions that factor into the engineering decisions. So just to close off, I know we're up against time, but when I was watching the video of your presentation at, I think it was Pipeline Conference, which I'll put in the show notes, but you cited this guy, I think his name was Swardley or something, but
Simon
basically
Wardley, yeah.
What's his name?
Simon Wardley, his name is.
Simon Wardley. Yeah, so basically, and I looked at this blog post that you referenced, basically he had some really ambitious and interesting insights and strong opinions about serverless and where things are going. And it sounded like you may not have as strong opinions, but I did want to ask, do you have any unconventional opinions or predictions about serverless and its implications?
Literally, I find now on a week-by-week basis, I am thinking more and more that this is how we're going to write software in the future. That's just because, almost just through evolution, that those of us who do in the industry, and those companies that kind of embrace it early, because it's not perfect. We haven't even talked about the downsides, but there are some for sure. It's not a free lunch, but those that embrace it early are just going to have such a competitive advantage that they're going to naturally rise, I think, above those that don't. For your average company, that it's just going to kill people off. So I'm thinking more and more now. It doesn't suit all use cases for sure, but I definitely think it's how we're going to go forward. I mean, I'm going to nick what Simon Wardley says. Like, he basically says all the things I'm far too brave to. But he has this concept of mapping, which I won't go into here. But it's all about kind of building on. There's a pattern over time of companies that build on the capability of that other companies have built, and they're the ones that succeed. And you can kind of track these patterns of time, that capabilities emerge. They become kind of an invention, but then they become more of a commodity, and then other people build on top of them. And history has shown that the companies that do this are the ones that are successful. And serverless compute is now a commodity. And so we're now in the age of companies being able to build on top of this, and those that do will outperform those that don't. And that's just based on historical trends of this. So yeah, I think it's going to be a game changer. It's very interesting to note even though as technologists we always want to be moving with the latest thing. There's a sense of inertia within technology, and I suffer from this as much as anyone. You've you've invested a significant amount of your time learning a certain technology, whatever it is, even if it was the hottest thing. We know how quickly things move. Suddenly, the industry shifts, and you're left holding the baby or whatever with this, which is not needed in this new world, and you fight it. And so in your company, you'll still use your skill because you've got it, even though the industry is moving on. And it's horrible, and it's what creates all that imposter syndrome that we all suffer with. But the industry doesn't care about stuff like that. So we even as technologists, we moan about the business, not wanting to adopt new technology, but we too influence this. And I think it will happen here as well. But yeah, my opinion is I think in 5 years' time, it's going to be a significantly different world in the kind of serverless landscape for sure.
Well, Robin, it's been great talking to you, and I enjoyed your material, and it's great to know that you're a listener of the show.
Oh, yes, no, avid listener for a year or so now. I'm a keen runner basically, so this is my morning commute while I'm sweating my way to work is catching up with whatever's new in the world of software. So thank you for keeping the pain away from my legs and distracting.
Absolutely. Look for a job more efficiently with Indeed Prime. Indeed Prime flips the job search model and lets you find a job more efficiently even while you're busy with other engineering work or coding your side project. You simply upload your resume, and in one click, you get immediate exposure to companies like Facebook, Uber, and Dropbox. The employers that are interested will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, the jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000 through Indeed Prime. It's 100% free for candidates. There are no strings attached. Sign up now at Indeed.com/SEDaily. Thank you to Indeed Prime for being a repeat sponsor of Software Engineering Daily. And if you want to support the show while looking for a new job, go to Indeed.com/SEDaily.
Wow.